Man who needs no introduction, Mr. George Williams with Reliability X.
Thank you. Let's see, that's running, right? You guys can hear me okay? Yeah. Whew, I was kind of hoping nobody would show up. I was interested in the closing work orders one. I wanted to kind of go down there and see that. I guess at another conference, Larry and I were kind of sitting, and after he had invited me to kind of be a co-sponsor and do some presentations here, we were developing a list of topics. And one of the topics was data standardization, just some basic best practice in setting up data structures. And so obviously the choice of who should be presenting that fell on the person who has the least amount of experience in EAM in the entire room, which is me. So hopefully this presentation is not way off base. It shouldn't be. They're general best practices. So let's talk a little bit about the configuration of EAM. So first and foremost, and this is probably going to upset, well, maybe not. I think all the IT people may have left. This should be a business project. The system should be owned by the business. And unfortunately, that doesn't always happen. Oftentimes, IT owns this project, and IT runs the project. And IT is a critical function in making sure this project is successful, but the system should be owned by the business. The business process is what EAM supports. And so the business should be directing exactly what the configuration looks like in order for it to support those business processes. They have to happen in harmony. The business process and EAM have to work hand in hand. And so sometimes when IT owns that project, it's more about getting the project done on time and on budget and less about how well it supports the business process. And so that project should be owned by IT. The next bullet point is really important. If you're not quite sure if EAM can do what you're looking for, ask. Either ask HxGN directly or ask your representative from the companies that are helping you, but ask. One of the largest things I run into is folks that have a system like EAM or many others, and they say it just can't handle what they're trying to do, and it's because they really don't understand the design intent of the system. And so if you find yourself wanting to do something but not quite sure how to do it in the system, ask questions, join forums, contact folks directly and get that information. So from a configuration standpoint, always begin with the end in mind. What data you want out of the system will help determine how you configure the system. If you're looking for information around all of your business processes, whether it's work execution, planning and scheduling, managing storeroom and inventory, or even warranty issues, understand what data standards are necessary for you to manage that effectively out of EAM. And what data may be required either from a regulatory standpoint or legal standpoint based on your industry also may have an impact on how you configure the system. So what data we're looking for from the system? Well, it depends on really where you need to improve. If it's things like maintenance efficiency, we're looking at schedule compliance, mean time to repair. So what data is necessary in order to achieve that? If we're looking for data like mean time to repair and we're using paper and it takes us 3 days to actually close out the work order, it's harder to get. I don't know exactly how long the repair time was. I just know the labor estimate that went inside of it. And that's not always the same as the actual duration of the fix. And then from a maintenance effectiveness standpoint, what about things like rework? How would you get rework out of the system? Rework out of the system in many cases is a timestamp based on when parts are issued. Or if you have a subsequent follow-up work order the next day or 4 hours later, they're really good indicators that there's rework going on. And if we want to know if our PM system is effective and we want to get out information like work orders that are derived as part of our strategy from PM, from PDM, well, we need a work order type for that. We need an order type that tells us that. And then on the operations side, I think we talked about this yesterday, having work orders where we're working on operational assets, but there's no part issued. And having dashboards and reports that pull that information out so we can get relevant data. If your data needs are necessary for decision making, require them. Adoption and utilization is not always driven strictly by procedure. If you need the data, require it. And be upfront about the effort necessary to properly configure the system. This is another area where implementations tend to struggle, not fully understanding the amount of work it is to get it configured properly. And then we end up either cutting corners on the delivery, or worse yet, we cut corners on training. Oftentimes, if we don't properly configure a system, we either blame the system, blame the vendor, and we end up with just a fancy filing cabinet. You can spend a lot of money on a filing cabinet. The system's here for us to be able to make decisions, and it's an extremely powerful system. But it's only as powerful as well as we configure it, and as well as we can gain adoption and utilization. And unfortunately, as well as any system is designed, it can still end up a filing cabinet. And we want to actively avoid that. One of the key pieces to actively avoiding that is understanding what the requirements are from the business. Whether the project is run by IT or not, understanding what the requirements are for the business makes a difference. Document your user requirements. When we write user requirements, they should be pretty straightforward. They can't be ambiguous. The IT folks and support folks that are helping you configure the system have to interpret what you write, so it has to be pretty clear. If we write a requirement that says the system logs us out after 3 unsuccessful logins, it could be a 5-year period of time and you get logged out. That's not the intent of what you're looking for. So we have to write the requirement appropriately. On the equipment and asset side of things, let's walk through what we need to know. You guys have seen this already a couple of times, but we're going to focus here on the asset portfolio side and how we structure data inside EAM to ensure a clean hierarchy. So we have to know, what do we own, how critical is it, and how does it fail? All of those things sit inside EAM. All of that information sits directly inside EAM and drives what we work on and what priority that work has, and what our maintenance strategy is. So first and foremost, we have to define what an asset is. What constitutes becoming a record inside EAM? And this really because I've had sites where ball valves are listed inside the database as an asset, and they're not usually an asset. My basic definition is this: if you will replace components on it or calibrate it, it's an asset. If the only thing you're going to do is throw it out and put in a new one, it's a spare part. Now, calibrated instruments are different, right? We often throw those out, but we have to keep track of the calibration, so it becomes an asset. It's not an all-inclusive definition, but it is a good starting point. So if we will replace parts on it, it's an asset or a piece of equipment. If the only thing we're going to do is toss it out and there's no regulatory body requiring us to track it, it's a spare part. And the good thing about structures inside EAM, you can have systems, you can have assets, you have layers of assets, and then layers of components. And so you can build a full structure and hierarchy. Also remember, teach finance and IT that there's a difference between a financial asset and a maintenance asset. Oftentimes, finance just wants to put in the financial assets. Or worse yet, even though it costs $5,000 or whatever the threshold is, even if it's something you just throw out, they want you to put it in the EAM as an asset, even though your strategy is not to maintain it. But because you capitalized it, they want to see an asset record. A maintenance asset and a financial asset are two different things. From a maintenance perspective, we're trying to track work and costs. From a financial perspective, they're trying to track depreciation and life cycle. They're not always the same thing. It's not a one-to-one relationship, especially if you acquire something. If you buy a whole line, usually it's got a single financial asset barcode. But that's not the structure you can build in EAM. I mean, you can, but it's not very effective. And so we have to break the financial asset down. Just a basic example of a typical air handler, we've got lots of things. We've got filter beds, we've got preheat coils, we've got fans, we've got motors, we've got VFDs. Not everything here is an asset, but in EAM you have a system for the air handler. You can have a system for all HVAC equipment, groupings, and then this particular air handler belongs to that. And inside the air handler, we have specific assets. We've got a supply fan, we've got an exhaust fan. If they're motor-driven variable dampers, then we've got those. We've got VAVs. But is the preheat coil an asset? I wouldn't recommend it, even though you do work to it. So if it pops a hole and somebody's got to go do some brazing, you're going to write a work order, but you can write the work order to the air handler. You're not interested in financially tracking the level of detail down to the coil. Not usually. And what about all of the instrumentation? That's going to depend. That's going to depend on whether or not it's for reference only or whether or not you calibrate it and you want to track the calibrations, even if they're outsourced. How about the motor for the supply fan? Is that an asset or not an asset? So remember my rule of thumb. If you're going to actually get it repaired, send it out, and it's a rotating spare, ends up back on the shelf, then yeah, it's an asset. It's an asset and spare part, right? It's a piece of equipment and a spare part. If all you're going to do is throw it out and put in a new one, not an asset. You can track that at the supply fan level. It has to be used, like people have to find the asset. And if your hierarchy is so detailed, what happens when they're out in the field and they have to select what they're working on? What do they do when they write a work order from the field? It just goes to the air handler anyway. If it's too complicated, folks will not drill down to select the appropriate asset. It's not that the level you cannot build it perfectly. Of course you can. But it also has to be relevant data that you're going to do something with. And if they're not going to drill down, you run into some issues. So we've got a whole system here that ends up inside our hierarchy. In this case, we've got a packaging line, and we've got in-feed conveyors and a scow and an exit conveyor and an x-ray machine. All those stations are part of a larger system for that production line. We want the granularity to be high enough that people will actually select the right thing, but detailed enough to give you what you need to make decisions later and have a good strategy. Oftentimes, folks will say to me, well, what's the value in it? And that's a crazy question to me, but from my perspective, class structure has a significant amount of value, especially from a planning perspective. If I have a class structure for a motor and it's got a frame size and a horsepower and a voltage and an RPM number, I don't need to know make and model, do I? I don't need a US Motors model number, blah, blah, blah. I need a motor that's got that frame size, that horsepower, that service factor. And if I have a failure in a plant, I want to know wherever else I use it or what sits in the storeroom that has the same class structure, not the model number. There's caveats to that. If you're in a validated system and you've already validated down the model number and you have to do like-for-like changes versus like-for-kind, and whether or not you got to manage change management, I'm well aware of all those things. But generally speaking, we need class structure. The other advantage to class structure is it should be building your descriptions. If you have a well-defined and populated class structure, it should be defining the descriptions of your materials and your assets, because then it is consistent. How many people search the word bearing and you get 500 results that all just say bearing. It's very difficult to find the right part or know whether or not you have a bunch of duplication in the system that way. Class structure and the ability for class structure to help you populate descriptions eliminates those issues. Now, it's very clunky to get there. It's a lot of work to get there. But if you have a planner or the planning function, part of the planner's function is to populate this whenever they plan work. And so over time, it becomes populated. Otherwise, you can spend a ridiculous amount of money to have it populated. From a naming convention, again, best practice, in my opinion, is to allow classification attributes to build out your descriptions. I'm also not a fan of smart numbers. There are fields in the system that typically house the information you are trying to cram into a smart number. And smart numbers eventually bite you in the butt. If I have to decommission this piece of equipment and put in a new one, I can't use that number again, right? So then what? Now I'm using other fields. Now that we have a hierarchy, we've got to determine how critical it is. And the asset criticality is what drives that. Asset criticality allows us to define the business risk of the asset going down. This helps us understand where our resources should be focused. Don't underestimate the utilization of this. It is a product score of both the impact or severity risk of the business. What happens when the asset fails? What's the safety impact, the environmental impact, the business impact, or operational impact? As well as the likelihood of failure. What's the probability of failure? We multiply these two things together to give us a priority or criticality score. Next big thing, understanding closing codes. The closing codes associate to symptoms, problems, causes, and actions. This is the equivalent output of an FMEA. So if we do a failure mode and effects analysis, we typically end up with a list of failure modes. And those things are associated to what happens out in the field. So for example, on the screen, we've got a basic pump, right? What are the functions of a pump? To displace a medium, I have to push some product, whether it's solids, powders, liquids. I've got to displace a medium. I have to displace that medium at a specific flow rate and at a specific pressure. I also have to contain the medium. I'm not allowed to leak unless I have a packing gland, in which case I have to leak at a specific drip rate. So those are the functions of a pump. Displace at a specific flow, displace at a specific pressure, don't leak. So then it's how can it fail to provide flow? It can fail to provide flow by a coupling failure, by a motor failure, by a pump bearing failure, by impeller wear. There's lots of ways we impact flow. The closing codes and problems should equate to those failure modes. Capturing this data allows us to report on it. Which seal manufacturers have the most failures? What failures am I seeing in the field but I don't actually have a PM strategy for or a task for? That data analysis is pretty straightforward. The PM tasks and task lists should be designed to associate to these. You're trying to mitigate a problem by doing the PM. The value of closing codes, well, we can do a Pareto analysis. Show me the closing code, problem code that we have the biggest issue with. Which ones are the most frequently used? That would be other. You should never have other. It should not exist in your list. Or don't make them so crazy that no one's going to scroll through them because they'll just select whatever is the fastest one to get to. It has to be user-friendly. It has to be, you have to see adoption and utilization. Which closing codes do we never use? Because maybe we have all these PMs that go out really frequently to address these types of problem codes, and we don't really need to address them that often or at all. There's a significant amount of value in the closing code. On the material side of things, big fan of either dumb numbers or UPC code. If you can actually get down to UPC code, that's fantastic. The trouble with that is not everything has a UPC code, and oftentimes we manufacture some of our own parts, so you have to have a way to differentiate between parts. You can't reuse somebody's UPC code, right? So you have to be able to differentiate that. Second piece of advice, always use class and commodity and item. If you want someone from the mobile application to be able to find a part, that's the fastest way. Because they'll go electrical, switches and relays, right? And then select, they only get a list of what's there. They're not trying to search the description. So always take advantage of class, commodity, and item. This also helps you organize the storeroom, because the storeroom organization happens one of three ways. Either it's by class and commodity, so all my electrical components are down this aisle, and then by commodity I get them down to item. Or it's organized, in some cases, in a hybrid fashion, where if it's a part that's specific to only one asset, because it's so unique, those parts are together, but then the rest of the room is in commodity. Or it's organized by what moves the fastest. So the things that move the fastest are closest to the counter, the things that move the slowest are further from the counter. But the most common approach is by commodity and item. So filling this out allows you to quickly reorganize the storeroom. From a naming convention, use commodity codes and class attributes. So class attributes, again, should be driving our descriptions, so we don't just end up with bearing, motor. How cumbersome is it to find your inventory if the entire description on 50 different things that you store say gearbox, and that's it? Definitely avoid smart numbers for inventory unless it's the UPC code. And in the storeroom, set yourself up for success to be able to do reorder point analysis. Oftentimes, our inventory levels are driven by what the supervisor wants us to keep on the shelf, with no math behind it whatsoever. Reorder point analysis uses daily demand, lead time. And lead time, by the way, when you're doing the math, should be coming from the database, from the purchase requisition initiation date until the receipt of goods, not what you populated in the lead time field. So we use the criticality of the component, daily demand, the standard deviation of lead time, and the actual lead time to calculate safety stock, reorder point, and economic order quantity. To do that, we have to have the information in the system, including criticality, because service level is based on criticality. We can't just say everything needs to always be in stock. So we have to go through the criticality piece for storeroom parts. Manage all of your parts. Oh, that's one of the biggest pieces. Oftentimes what happens is somebody needs something and they say, well, order 2 of them. And they put it in their pocket and take it to the shop and they sit there. If you use the system to drive your inventory math, and that part doesn't get used for a long time, it impacts your daily demand. And if I see no demand, the math is going to tell me don't stock it. And I pull it from the inventory, and then eventually they need one, and they show up, and we don't stock it no more, and they blame the storeroom, they blame EAM, they blame the math, they blame the report, but they don't blame their bad practice of ordering too many and shoving them in their hidden stores. So you have to be able to control the inventory in order to let EAM and its reporting capability drive the storeroom. That's all inventory. So that's all satellite areas, shop stock, truck stock. You can set those all up as their own storeroom. And then you have the main storeroom do the replenishments electronically. That still takes discipline if you're not a staffed storeroom. Somebody has to actually fill out what they take from the room. Let's move on to work orders. Statuses are necessary to manage your workflow. The system has 2 levels. You guys are probably way more aware of this functionality than I was a week ago. But generally speaking, you have system statuses, and then you have so you have system codes. They're the main statuses, and then you have more user-defined statuses that sit within each of those system codes. The reason it works like that is at the system code level, it restricts or allows certain functionality and movement. And then all of the subsequent statuses that belong to that system code inherit that functionality. And so you have to define both levels. You define the system code levels, and at the system code, what gets driven, and then you have to define the remaining work order statuses. In this particular sandbox, there's a system code bypass due to nesting. So that's for nested work orders, child, tasks and all that stuff. Everything usually comes in either new or unapproved, or it's some type of newer status, which is a work request that gets converted to a work order. All the work we do up until a point that it goes out into the field is a waiting release. And then everything that happens when it's in the field is released. And everything that gives you a solid stop, including canceled, is a closed status. Or a completed status in this case. And the number that you have of user-defined statuses or statuses related to system codes that you create is going to be based on your workflow. My advice here is pretty straightforward. You need enough statuses to know whose phone to call. If you're not sure whose phone to ring, you don't have enough statuses. Only one person or one role should own a status. So I should know whether I'm calling a supervisor, the planner, the scheduler, the storeroom, or the technician based on status. If you're not sure and that's gray, you don't have enough statuses. Because I want to know stagnation of work. How long's it been in that status? So I need to know whose phone to ring. The priorities designed to give you some metrics, and these define response time. How fast do I have to respond to this work order? Emergency, fire, flood, loss of production. These are just general rules of thumb. Something urgent, I've got to show up within 24 hours, but I don't have to stop the job I'm currently doing to go respond. In the sandbox I have access to, there's one called very important. For me, this is anything that cannot go through the planning process. I don't have to get there today. I don't have to get there immediately, but it really doesn't have time to go through the planning process. And then we've got important work, everything that can be properly planned and scheduled, and non-critical work, which is fill-in work. Let's talk about work types. First and foremost, there cannot be any ambiguity. You have to eliminate ambiguity. If you have a work order type of breakdown and a work order type of corrective, well, I can have corrective that causes a break that came from a breakdown. Now I've got a gray area. How do I know how much corrective work I had against something? I now have to write a query that combines 2 things. Again, because in EAM you have system codes. You can have a system code for corrective where both breakdown and non-breakdown corrective exist. And then you can drive downtime requirements based on breakdown maintenance. And emergency is not a work order type. Yeah, it's a response time. Emergency is a response time. It is not a work order type. And that creates ambiguity, right? If I want to know how much corrective work I did on a system, I have to include the stuff that says emergency now. And I've got to write different reports and write different queries. And it's not necessary if I don't have gray lines. There's not gray areas. We have to get rid of the ambiguity. Basic work types corrective, anything that's functional failure, whether it's breakdown or not. A breakdown is just a corrective maintenance work order that also has downtime. A customer request, so somebody needs something in their office, an outlet. The CEO says, hey, by the way, I have a friend coming that gave me a picture 10 years ago. He's on his way here right now from the airport. I need a picture hung. It's not breakdown maintenance. It's an emergency, but that's priority, not an emergency work order. But you just basically have a customer requesting something. Then you have preventive maintenance, predictive maintenance. I'm a big fan of something that says troubleshooting or evaluation maintenance, because oftentimes we're not quite sure what the problem is yet. So we send somebody out to troubleshoot. They can put in a follow-up work order that's corrective in nature so that we can properly plan, schedule, get the parts in. Setup work order. This is two buckets for me. One is things that are seasonal, like starting chillers up, starting boilers up. There's no corrective going on here. And the other one is every time we go help operations and we want to segregate that work to show them how much time and money we're spending doing their job. Or you can have a separate one that says operator assistance, whatever you like. I like something that says it's a work order that came because we inspected and did our job. And it doesn't really matter what you call it, but something that says it's a preventive or predictive response. We found it proactively, because that's why the PM program and why your predictive maintenance program exists. So you want to be able to take credit for that. We didn't impact operation. We didn't have a catastrophic failure because we found it. Calibrations, obviously. By the way, it was awesome to see that calibrations now has significant digits. I was really excited when I saw that on a slide in Kevin's presentation. That's huge, huge functionality. If anybody's not sure what that is, if I have a calibrated instrument with a tolerance of X and I'm putting in my values and I need 3 zeros and then a value, and accidentally the technician puts in 4 zeros and a value, it passes calibration when it shouldn't have. That functionality is significant for folks that are in life sciences or industries that can be audited. The last thing you want to do is not have an OOT when you were supposed to have an OOT, out of tolerance event. Capital projects, and you guys have a whole suite of managing this stuff, including shutdowns. Take advantage of that functionality inside EAM. Some basic general advice before we wrap up here. Don't put in the description what specific fields can house. If you've got this extreme long description text that has make, model, serial number because you migrated it from a previous system, rip the Band-Aid off. Get it put where it belongs in the system. It's only going to help you later as you go through upgrades. Or next time you are, well, like you guys just do patch releases, so you're going to have to rip the Band-Aid off. Get it out of there and get it in the data and where it belongs. The system is more powerful if you're taking advantage of the fields that exist and for the design intent of which they exist. Understand the design intent before deciding to use a field for some other workaround. You may inadvertently use a field that later in your maturity you need and now can't use. And then you go, I can't use the system, it doesn't do what I need it to do. Because you decided to use priority to house what color the asset was. And now I can't have criticality. Yeah, but even in that case, folks often just go, well, this field's already a drop-down and it says yes, no, so I'm going to use it for this purpose. And then later, the functionality they wanted to use it for is gone. So understand design intent long before you try to utilize systems. Join lots of user groups, message boards, stay engaged, And don't be afraid to rip the Band-Aid off, because all you're doing is delaying the inevitable. Whew, there's so much more. Oh my goodness. I would also highly recommend, not that I'm trying to be self-promoting here, but I would highly recommend you have somebody on your team as you're going through, well, what can we do to improve utilization, that has business use experience.